Hey guys, here are your notes for section 2.2, and let's start us off with a mad gap just to see if you can get it and bring it to me tomorrow. First one, paper, own, heap, heats. Ah, that's the first one. And the second one, gnome or deers. So good luck on those, and if you bring those to me tomorrow, you can put them in the bucket. Get a prize. All right, these are short notes. They're just a couple slides, actually just three. Not four. This is four. There's something else on one of them. Testing for parallel lines. So we want to actually see now if lines are parallel. There's ways that we can test. And section 2.1, we just learned about the special pairs of angles. So some of those special pairs of angles can be used to test if the lines are parallel. Now the special pairs of angles that we learned about yesterday were the ones that are on this chart right here. You've got your two parallel lines cut by a transversal, and you've got corresponding angles like A and E, or B and F are corresponding because they're both in the same position. D and H are corresponding. C and G are corresponding because they're both in the bottom left corner. So you've got those kind of angles. There's alternate interior, alternate exterior, and consecutive interior. Some of these pairs of angles can be used. So if any pair of angles, or if any pair of corresponding angles are equal, like A to E, if A equals E, you could also put if B equals F, or if C equals G, or if D equals H. If any of those are going to be equal to each other, then these lines have to be parallel. If any alternate interior angles are equal, so like C equals F, so if C and F are equal to each other, or if D and E are equal to each other, if you measured E and you measured D and they came out the same amount, then you know these lines have to be parallel. So if any pair of corresponding angles are equal, or alternate interior angles are equal, or alternate exterior angles are equal, like B and G. If B equals G, or if A equals H, then you know these lines have to be parallel. Those are alternate exterior angles. And the last one, if any consecutive interior angles add up to 180, like if D plus F adds up to 180, or if C plus E adds up to 180, then you know these lines have to be parallel. There's no other option. If any of these happen, then the lines must be parallel. So then this orange line must be parallel to this orange line if any of these four things happen. If you need more time, you can pause it. Just move on. Okay, so here's some examples. Are these two lines proven to be parallel? And the answer is yes, they are parallel because corresponding angles, they're both in the upper right corner here, are parallel or equal. So these two corresponding angles are equal, therefore the lines must be parallel. The second one here, below it, 81 and 101 are called consecutive interior. If they add up to 180, then they're parallel. Does 81 plus 101 add up to 180? And the answer is definitely no. 81 plus 101 adds up to 182. Those are not parallel lines. Eventually those would touch because they would get really close to each other. These are not parallel because a pair of consecutive interior angles do not add up to 180. So they can't be parallel. These two, they're both 70s. And again, pause the video to copy that down and then move on. These two are both equal, and they're called alternate interior. So these lines are parallel because alternate interior angles are equal. This angle equals this angle. Therefore, these two lines must be parallel. So that's just a way to prove if lines are parallel. You use the angles to prove it, just like we did in our constructions when we measured the angles to make sure that they were the same, that we knew that the lines had to be parallel. You can, again, pause it if you need to. Now I want to show you a little something here. I want to show you about corresponding angles. Some of you may not understand corresponding angles. If I was to take this group of angles and move it down on top of this group of angles, notice that they're exactly the same in the same position. Like 1 and 5 are equal. 2 and 6 are equal. 3 and 7 are exactly the same. 4 and 8 right on top of each other. Those are the corresponding angles. So 1 landed on 5. 2 landed on 6. 3 landed on 7. 4 landed on 8. Those are called corresponding angles. And if you look at them, they're identical. They're exactly the same. They're congruent to each other. So when lines are parallel, that means this line must be parallel to this line because all the corresponding angles are equal. That was just something for you to look at. You don't have to write it down. And the last one here, just some examples. What can we say about all the angles in this figure? Well, we can say that angle 1 and angle 2 are going to be supplementary. Okay, and also if we know that this line is parallel, so we put a little arrowhead right here. If this line is parallel to this line, and we put an arrowhead right there, then 1 and 2 we know add up to 180. We know 1 and 3 are going to be corresponding angles. They're going to be equal each other. And we know 2 and 3 would add up to 180 because they're consecutive interior. So 1 and 2 are supplementary. Because they're a linear pair. Okay, so that's one thing we could write down. Second thing we could write down. All right, you could also say that we said angle 1 and 3 are congruent. Because they're corresponding angles. So they're both in the exact same position. They're both in the top right corner, so they're going to be equal angles. And then we could also say that 2 and 3 are supplementary because they're called consecutive interior, and they have to add up to 180. So that's what we could say about the angles in this figure. As we go across, it says solve for x and y. So if I look at x here, I know that x and 67 are going to add up to a straight line here. So I know that x plus 67 has to equal 180 degrees. So that's what I know. So all I need to do is subtract 67 on both sides. And you'll get x equals 123. No, 113, sorry. I learned how to subtract correctly. 113 for that one. So x is 113. Now, what do we know about x and y? Well, x is up here in the top left, and y is down here in the bottom right. They're alternating, and they're exterior. And if you look back a couple of slides, alternate exterior angles are equal if the lines are parallel. So that means that if x is 113, it means y is also equal to 113. So that would be alternate exterior angles. So that was number 2 there. Down here we've got, again, alternating and exterior. So we know that 5y has to equal 115. So this 5y is exterior and alternate to this 115. So if you divide by 5 on both sides, you're going to get y equals 23. You get 23 as your y value on that one, and you're just solving for y. This last one right here, 5x minus 24 is this angle. 89 is this angle. We have to decide, are they equal to each other or are they going to add up to 180? And let's plug 89 into some other places. I know that this is also going to be 89 because those are vertical angles. That's the one I could put. I could also put 89 here because those are alternate interior. So 89 can go from here to here. So do you think these two angles have to be equal to each other? No, because they make a straight line. So we know that this angle is going to add up to 180 with the 89. So you're going to put 5x minus 24 plus 89 is going to equal 180 degrees. And then you want to combine your like terms. You're going to subtract here. So you get 5x plus, and when you subtract 89 minus 24, you get 75. No, 65. 65. You get a positive 65. Equals 180. Then you're going to do your subtracting 65 on both sides. So you'll get 5x equals 115. When you subtract 180 minus 65, you get 115, and we just had that over here. So y is going to equal 23. So your y value is 23. All right, we'll see you guys tomorrow.